Welcome 3 minutes, Kevin Galligan. Hi, welcome to the New York Android Developers Meetup. I'm Kevin, the president of Touch Lab. We are a kind of mostly Android shop, but we're definitely not just Android shop anymore. And we make cool mobile stuff. And we're hiring, of course, like everybody else. And how's it going? Okay. So the next meetup is Thursday, June 15th at Button. It's a summer bash because they have a rooftop and it's awesome. DroidCon New York City 2017. It says news is coming really soon, which is not true. So we're like officially happening September 25th and 26th. Woo! Okay. Call for papers is sometime probably in the next few days. I'm not sure yet because we just kind of signed contracts today. It's like last year, but probably 30% larger. That's all I can tell you. Yeah, so that's happening. All right. Thank you to our main host, SeatGeek, Dallas and Aaron for setting up and coordinating. And also thank you to everybody. I've been told there was some security delays. So thanks for putting up and or dealing with such things. Meetup lists things by first name, which is odd. So anyway, okay, cool. So we're gonna have our host welcome, Stephen.
Good evening, everybody. Thanks for coming on out tonight. I'll apologize on behalf of SeatGeek for the security issues. Appreciate also everyone not getting the memo on coming in on the East 4th entrance. This is a slight miscommunication on our part. The main entrance will be hopefully operational in a few weeks. So I'll introduce myself. I'm Steven. I am a senior Android engineer here on the Android development team. I've been with the company for a little over 2.5 years now. In case you're not familiar with SeatGeek and what we do, we are an event ticketing company. So we ticket sports events, concerts, Broadway shows, all that sort of stuff. We primarily focus on the secondary ticketing market, so that's ticket resale. But recently, we've launched our SeatGeek Open product, signed a deal with Major League Soccer, and started ticketing our first professional sports team. It's a very exciting development for our business. And actually, even more recently, we just acquired a ticketing company that was building the software that we were building our platform for that purpose on. I think that makes sense. Lots of growth here at the company, and we're very excited. So obviously, I got to give the same pitch Kevin did. We are hiring for lots of roles. SeatGeek.com/jobs. Feel free to check it out. And then I will be giving the talk this evening on some RxJava networking stuff in a little bit. So want to say thank you again for coming on out, and looking forward to talking to a few of you afterwards if you have any questions or anything like that. So pass it back to Kev here.
Well, I'd also, the last thanks is to Olivia for doing an excellent job. All right. And then Steven's going to talk about some RX things. Okay, cool.
Cool. Yeah, RX things. Specifically networking. A lot of your apps are probably connected to the internet. And I know ours is. We have lots of events that we show in our app, as well as things like tickets and other things that people are probably interested in. And we use RxJava pretty heavily to fetch that data from our APIs. I'm sure many of you have opened up an intro to RxJava tutorial at some point, and you've come across something that looks similar to this. You have your retrofit builder, and you're creating a pretty simple API interface. I think the canonical example is actually GitHub, but I changed it for SeatGeek. But you have a pretty simple API interface. You have this observable events response, a simple get call to your API here. We're calling it get upcoming events. You subscribe on an appropriate IO thread so you don't get a network on main thread exception. You observe on your main thread, and you do something with your events. This is like the example you've probably seen 100 times in intro to RxJava talks, and it sucks. This is just not good. If you're doing this in your code base, you're using RxJava wrong. And I wanted to talk a little bit more tonight about things you can do to make your code better. So before we can do that, let's just kind of identify some of the problems. Granted, there's a lot of problems there. Let's identify some of the problems that are actually wrong with that code. So here's some things that this code doesn't handle. It doesn't allow you to retry requests when they fail. It doesn't allow you to deal with specific response codes if your API has specific response codes. It doesn't help you show loading indicators in your user interface, something most designers like. It doesn't handle configuration changes. It doesn't have any form of subscription management. So obviously, common problem in Android asynchronous programming there, dealing with the activity lifecycle, that sort of stuff. And then probably other cases that you have in your application that this isn't solving for. So I hope today to kind of go through a few of these and give some hopefully coherent solutions to solving them. So let's see where we can improve. And let's start with what if my request fails? This is mobile. Requests fail all the time. The network is not reliable. You always have to count on your network request failing for one reason or another. So here, well, we've simplified our example a little bit. We have our get requests observable method. We can assume that this is generating an observable that we're subscribing to get our request. So as I said, mobile requests can fail pretty regularly, and you'll want some sort of retry mechanism. So the naive approach to doing something like this would be to override your on-error method in your subscriber. And if some condition is met, call the same make request method again that would then recreate the observable and subscribe. Hopefully all of you are sufficiently afraid of this code because this is making automatic retries to your server without any limit or condition to stop it other than the condition you've written. And I hope you've got that tested properly. So RxJava gives us a really useful tool called retry when. This is a little bit of a more coherent approach to doing some sort of automated retry. And the goal here would be maybe doing something like a back-off approach. And I'll explain how retry when works because it's a tricky operator to get the handle of. So retry when is called once per subscription. And so that means whenever a new subscriber comes, the retry when method will be called to fetch the function that will determine when this observable should retry. Passed into that function is an observable of the errors by the parent stream. So everything that happens above retry whenever there's an error, that error will go into the observable that's passed into that function. And then as long as the observable that's returned from that function emits something that is not an error, the request will retry. So in this case, what we're doing is we have our attempts. So that was an attempted request that failed. So that's a throwable. And we're saying zip width the range from 1 to 3. So that will count 1, 2, 3. So all three of the first 3 errors from this request. Then we're calling into a flat map where we are using the timer function to somewhat back off by multiplying it by the count of failures that we've had. So this will retry the request with a 5-second delay, then a 10-second delay, then a 15-second delay, and then it will stop because this observable inside the retry when completes. And once that completes, then the rest of the observable stream completes. So at least we put a limit on how much we're going to DDoS our own servers. Now, a lot of cases, these requests are tied to some sort of UI element, right? And so you want to allow the user to retry through a UI element. And so one thing you can actually do is that since this retry when is returning an observable, you can bridge the imperative functional gap by using something like a relay or a subject, and you can return that from the retry when method. Then you can have a retry view, and whenever that retry view is clicked, you can then call into that relay or subject and have it publish the retry when function, which will then resubscribe to the parent observable and perform your retry request. This way you don't have to recreate your observable every time. You can just reuse it. So what if your API has very specific response codes? Ours has some. I'm sure many of yours do. The canonical example there doesn't tell you how to handle them. So here, we're looking at, here what we've done is we've actually changed the observable type in our function up there. So you can see we now have an observable of a response of an events response. And retrofit handles this for you automatically, but you can actually write this yourself by wrapping OK HTTP. or excuse me, the retrofit call class. It's a fairly trivial implementation. But what you could do is once you have that events response, instead of getting the JSON handled representation of your JSON object that you're getting back, you actually get what's the response class from retrofit, which has a number of useful methods that provide metadata about the response object that was passed back from your server. So that allows you to get access to things like the response code, and then you can handle your 301s or your 403s or whatever code your server decided to pass back to you. But that's a little tedious if you only want to handle a few edge cases. So retrofit has your back. By default in retrofit, if there is an error message in the 400 to 500 level, it will go directly to the on error stream of your observable stream, and it will actually create a specific throwable error for you called an HTTP exception. And so you can use that HTTP exception. You can check in your on error here. If it's an instance of an HTTP exception, you can then actually get access to the response document or the response object that retrofit has, which will allow you to gain access to your response codes. You can actually get access to the body of the response in case you have specific error messages that your server is returning in like a JSON body as part of your error, a 400 level response. And this is a pretty easy way to handle it as part of your retrofit example here. So we just showed like a switch statement for handling various error codes. But I think there's a lot of cases in our app and potentially in yours as well, where you actually want to have multiple streams branching from a singular network request for handling different edge cases. So one way to do this is use the RxShare operator. And so you can have your standard observable that we're creating up here, your get API get upcoming events. We've got our proper subscribe, and then we're calling share. And now we have this observable. Share works by share is essentially a multicast operator. So from this point forward, all of the work that is done before share will only be done once, and all future subscribers will get the response data as long as they're subscribed in a sufficient period of time. So in the case of this API request, these synchronous subscribe calls here will be just fine. So what we can do now is we can set up some branches from our observable. We can see we have a specific case for when the response is successful. We have a specific case for the 403 response, a specific case for the 304, and these are all handled as separate subscriptions. So you can actually have methods in your unsubscribe there that are only called for those specific cases, and you can do other things in the branch in case you need to do specific mappings for the case where you hit, say, a 403 response. You need to specifically map to some other function. So my designer wants a loading indicator. We have a number of loading indicators in our app. And so the examples of how to do loading indicators in RxJava are usually wrong. And so I'm hoping to shed a little light on some good ways to do them. We'll start with the naive approach, similar to what we did earlier. So we have our observable here. We have our subscribe on and observe on, and we're doing something with our events when they come back. The first thing I think that everyone tries to do is they try and put their loading indicator methods directly into their observable stream. Who can tell me what the error is here? Obviously, we're doing something wrong. The issue is that we are directly tying our UI code into our data loading code. We've tightly coupled our loading indicators to our observable stream. And this actually leaks views, right? Since these are lambdas that are referencing fields, they're going to be using invisible accessor methods. And so these are going to leak your parent activity should you rotate or something like that. Now we'll go into more detail on configuration changes in a little bit. But the other thing too is that this can't handle a stream of events, right? You're doing something in the subscribe and unsubscribe events. If there's multiple events coming through, it won't be able to handle those cases. So this probably isn't the right way to do it. So what's a better way we could maybe do this? How about we split our streams? This is an approach that we've been using for a while here at SeatGeek, and I think it's pretty effective. So you can use something like a behavior relay or a behavior subject to represent the current state of your request. And now you can see we have a request state enum up at the top here for the idle state, the loading state, the completed state, or the error state. which are the 4 general states we think our request can be in at any moment. We're initializing our behavior relay to the idle state because the request hasn't been made yet. So any user interface probably doesn't need to do anything as it's going through. So now in our observable stream here, you can see that instead of calling directly into our user interface to set whether our loader should be showing or not, we're just publishing our request state. We're publishing it loading. Once it gets scheduled, I missed the call to in-flight, but there's a call to in-flight once the request is actually being executed. And then if it errors, we go to request error, and if it completes, we go to request complete. So what does this allow us to do on our UI side then? Once we have this relay all set up, we're able to come in here on the UI side, subscribe directly to that state relay or subject, and you can then just switch on your request state and update your view appropriately. So this is now separating our request stream from how it's being handled in the UI. And so you can then think about how this might apply to your favorite architecture, be it MVP or something like that, where your presenter is subscribing to this stream and then calling the appropriate methods on your views, and then you're inside your model layer, you're setting up all of the this state relay or something like that. We can also do this with all the other aspects of the request. So not just the request state. We can do this also with the result of the network request. We can do this with the errors that are encountered as part of this request. And so now we have a number of different streams that are all going as part of one request. And so you can see here we're subscribing our response and errors. And what this allows us to do is we can have various parts of the user interface subscribed to handle different parts of the request. So you might have one part that's showing loading indicators by subscribing to the state. You might have another part that's showing an error message by subscribing to the throwables that are being emitted to the error and then extracting the proper error message from them. So here's what it might look like on the UI layer. Then you have something that is subscribing to the state to update the loading view. You have something that's subscribing to the response relay to show the events. And you have something that's subscribing to errors to extract and show the error from the throwable. Of course, that can be a little bit messy if you've got all these various subscriptions going on and you don't think it's necessary for your specific request. You might want something that's a little bit more coherent, such as like a view model approach. So if you already have these 3 streams, you can take advantage of the very nice RxJava operator combine latest. And so we can combine our state, our current response, and our error, and use something like optional to represent whether or not something is available. And we now have a request view model that will represent the current state of our request. So that will include our request state, whether it's in flight or completed or errored, and then our successful response or our error, which may or may not be available depending on the current state. So you can see now we have a pretty succinct combined latest call here to combine all of them together. And now we can subscribe with our view or to the view model from our view, and we can just update based on what that view model looks like. With this approach, you can very easily handle multiple requests all going into the same subscriber. You can also handle something like pagination, where you might have multiple responses coming into the same view model. It's very flexible. It gives you a lot of power there. So what about configuration changes? One of my favorite interview questions for junior Android candidates is asking them about the async task and what are the problems with async task. And seeing some thumbs down and people, yeah. Async task is brutal sometimes, because for a new developer who's going through the Android documentation, they think that this is the right way to do stuff in the background. And that's just not right. There's so many problems with the async task API. But the problem is that a lot of times we push things like RxJava on junior developers and we say, this is a better thing than async task, you should use this. But they don't have a clear understanding of why it's better, because out of the box, RxJava doesn't actually solve any of the problems with async task, other than like maybe a more coherent API or something like a little bit easier to work with, I guess, from thread scheduling perspective. But outside of that, like, it's not tied to the activity lifecycle. You can still very easily create memory leaks. There's lots of problems with less advanced RxJava code. So let's come back here to talk a little bit about subscription management, because this is probably one of the more challenging things that people deal with when they're writing RxJava code. So In RxJava 2.0, the subscription class changed to the disposable class. They function effectively the same. You can see we have our combined latest here where we're combining our state, our response, and our errors into our view model. And when we subscribe, you'll notice that we're holding on to the disposable object from the subscription. So at some point, we can then call disposable dispose, which will cancel our subscription and release, whatever references might be in that subscription chain. But the question is when? When do we make that call? So I'm calling this example basic disposable. This is kind of the most simplistic approach that you can take. In this approach, where at some point during our activity here, we are making this call to our network request. We are holding on to the disposable from that network request. And then in our activities on stop method, we are disposing of the request and we're not worried about the subscription anymore. This is totally fine. This is preventing your subscription from leaking during a configuration change. There's obviously some issues with it. You're not resuming your requests and doing things like that. So let's take a look at how we can kind of take this to the next level. Actually, before we get to the next level, I wanted to point out a very helpful, useful helper class called Composite Disposable. This used to be Composite Subscription, which allows you to manage multiple disposables at the same time. So when you create a subscription to an RxJava or observable here, you can then add each of the disposables to the composite disposable. And then at some point when you're going to dispose of all of them, you can then just call the clear method. The clear method is distinct from the dispose method. The clear method disposes all of the current subscriptions and then clears out the array inside the composite disposables. Calling dispose will do the same thing, except it will then not be able to accept any new additional disposables into the collection. So one thing that got deprecated and then undeprecated in the Android framework is this handy little method called onRetain non-configuration instance. It's a long time. There's a many-starred issue on the Android bug tracker for undeprecating this method. Anyway, which finally did happen. I forget when, but one way to persist things across activities outside of storing them in your bundle for save instance state is to take advantage of the non-configuration instance. And this is simply an object that you can pass from one activity to the next one during a configuration change. So if you have an observable stream, it obviously can't be parceled because it doesn't implement parcelable. Be very difficult to try and create some sort of system for parceling and recreating an observable stream. So what a lot of people will end up doing is they'll end up using some sort of static, some sort of static field or some sort of thing to persist observables through activity rotations. I'm here to tell you that you don't need to do that. You can do that as part of your activity and not lose scope. You can keep things scoped to that activity. So here's an example of how to use non-configuration instance. So you can see here, at some point in our activity, we are creating our observable, assigning it to our request field. And then we're also subscribing to it and keeping a reference to our disposable. You can see in our onStop method, we are calling disposable dispose. But since we use the cache operator on our observable, it doesn't mean that our observable will stop executing. It will just cache that value and you're holding onto a reference to it. So as you're going through your configuration change, and you're coming back into the next instance of the activity that your user is currently viewing, you can see in our onCreate, we're calling get last non-configuration instance. And this will actually call directly into the previous activity before it is destroyed, and it will get that observable that you have saved, and it will return it to the next instance of the activity where you can then proceed to resubscribe. So you can see here in our onStart method, as long as we have our request and our disposable, if we're already not subscribed, we'll go ahead and resubscribe to that request. And that will allow us to continue that observable request through an orientation change. Fortunately, managing disposables is a little tedious, and people have come up with better solutions for doing that sort of thing. The one I'm going to recommend is Rx Lifecycle. I assume some of you are probably familiar with Rx Lifecycle. It's a library put out by Trello, specifically Dan Liu at Trello. But the the gist of it is that you can use this handy bind to lifecycle method that's included in their Rx app compat activity, Rx activity, Rx fragment, that sort of thing, that you can extend your activities and fragments from. You can also use it statically if you choose, but I find it easier just to extend from their classes. And then instead of having to manage the disposable yourself, once you get to the point where your UI is safe to subscribe, you can go ahead and just call compose bind to lifecycle. And what this will do is it will create a transformer. A transformer is a construct in the RxJava world that allows you to manipulate an RxJava stream inline. Think of it as something that can apply more operators to your RxJava stream as it's executing. And what the transformer does here is it binds your observable to the lifecycle of whatever object it is currently a parent of. And that is actually defined at like each level. So a fragment has a different lifecycle than an activity, obviously. And so there are enums that enumerate the various lifecycle states that each activity or fragment can be in. And what happens is as the activity is working its way through its lifecycle, there's a subject, an Rx subject, that is getting published with all the various lifecycle states. And as the corresponding state to the one that your request was made in is called, it will automatically unsubscribe your observable. So an example would be, if this method is subscribed to in onResume, as soon as onPause gets called, it will automatically unsubscribe from this observable. Same thing with onStart and onStop, onCreate, onDestroy. These are the, at least for activities, these are the ones that are set up automatically for you by Rx Lifecycle. This is pretty handy because we don't have to manage our composite disposable of disposables. We're kind of solving for the 95% case where you usually want things tied to your activity lifecycle. So what if we wanted the best of both worlds, where we have Rx Lifecycle as well as our retained non-configuration instance? So you can see, instead of holding on to our disposable here, when we are creating our observable cache, we were just, the first time we were just calling compose bind to lifecycle here. And then again, we are getting our last non-configuration instance and onCreate. And then in onStart, we are checking to see if we have a request and then resubscribing to that observable. And this will allow you to persist your observable streams throughout configuration changes. One thing that I'll point out is that this retain non-configuration instance doesn't have to just be an observable that it goes through. It's just an object. It can be any object. And so an architectural decision that we've made in our application, and I've seen in other examples of, is that we actually store our Dagger graph that is scoped to that activity as that retain non-configuration instance object. And then we inject, using Dagger, are either observables or presenters that are applicable to that view from that graph, and then it is persisted through configuration changes. That way we can have our presenter be subscribed in this orientation, it persists through the configuration change, resubscribes when onStart hits again. So here's something that I wanted to show off. If you're using an MVP-like approach in your application, what you can actually do is you can actually create your own lifecycle transformer and mirror the functionality that exists from Rx app compat activity or Rx fragment. And so you can actually bind your observable subscriptions to the lifecycle of your presenter. And so in our case here, you can see I've created a presenter lifecycle. It's an enum that shows off the lifecycle of our presenter here, whether it is stopped or started. And then you can see we have a bind to lifecycle method. And this is what you'll use inside your presenter, your subclass presenters, to bind their subscriptions. And so you can see here, we're utilizing this RF lifecycle bind method, and we're passing in our binding mapping. So you can see that we're mapping from started to stopped and from stopped to started. And these are the corresponding mappings of the lifecycle that will then be used as part of our presenter there. And this would allow you to do is then have inside your presenter, you can have your observables that will then be automatically persisted through configuration changes because they're part of the non-configuration instance. And then they will be subscribed with the appropriate lifecycle. So you never have to worry about your observables inside your presenter emitting while your view isn't available. Your view will always be available when an item is emitted from your observable. And I think that's pretty nifty. So, any questions? How'd I do on time? Did okay on time. Awesome. Lisa. Yes. Here is my Twitter at SDDemico. Here's my GitHub, SDDemico. I think also my, what is it, SlideShare or whatever it is SDDemico. So I'm SDDemico everywhere. I'll have these slides up tonight. So you can go ahead and take a look at these examples and check them out, that sort of thing. And one last shameless plug for SeatGeek.com/jobs. So cool. Thank you, everyone. And I'll be hanging around afterward. I work here. So see ya.
Yeah, I was going to say thanks for asking about the slides, because that was really interesting. Going back a few years, you know, when people were like, what about RX? I'm like, well, what about config change? And they're like, well, I don't know. I'm like, well, you can't release something that's worse than what already exists. So I guess thanks to Dan and company for sorting that out. And thanks to whoever decided that a config change would restart the activity. Thank you from all the consulting companies in the world that get the charge to figure that out for people. All right. Sorry, comedy. Next up, Yousuf. Going to talk about Conductor, which is the thumbs down to fragments.
Hello, I'm Yousuf. I work at Restaurant Brands International. Just Google it, it'll be easier. Raise your hand if you have an opinion on fragments versus views. Not that many of you guys. Raise your hand for views. Fragments. All right. The point of this talk is to explain that views only are actually like missing a key piece of like the whole view component like idea. And then if you guys believe that, why you should use Conductor instead of fragments. So kind of like an understood point is that like complex applications need like view components. Imagine if your whole application was just one view hierarchy, you'd like shoot yourself. You need some sort of way to break things down, to be able to consume them in smaller chunks, to be able to reuse things and move them around as you need them. You need to reuse XML layout. You need to reuse view logic that you append onto that XML layout. You need to build responsive UIs, like for varying form factors, tablets, multi-window, watches. Good luck with all the different aspect ratios that there are for Android. Encapsulation. If you don't encapsulate your views, you're going to have like tight coupling between everything, and refactoring anything is going to be a nightmare. And then ease of testing. If you have small views, then they're like kind of single purposed, and they can be more easily testable. So, break your views into components. If you aren't already, you'll probably have a better time if you do. All right. So what were the options before fragments were introduced? You have the include tag, which you can just like kind of copy, cut, and paste an XML layout from one layout file that you have into whatever you're trying to include it in. It's really good for just reusing XML, but it doesn't let you reuse programmatically built views. If you're using something like Litho, Anko, or just building Java views yourself, then you can't use this include tag. There's no view logic bundled with XML. Like if you want to do something based on some data, or you want to even just count a timer once you put this layout on the screen, there's no logic that you get with XML. There's also no lifecycle. You just goes onto the screen, and that's kind of it. It's really good for simple use cases, but not really like that component thing that we're talking about. That's when you elevate one level higher. Custom view groups and views. It's really good for programmatic views. You can build you can use Anko, whatever you want to build, just a view instance programmatically, or you can inflate it via XML, whatever you need. And then whatever view logic you have, you can also reuse that, because you're kind of extending a view group, and whatever you need to do gets reused as part of that view itself. You get with this and the on inflate, on attach window, on detach from window lifecycle methods, you kind of get like pretty close to what you need to build a view component. Everything is kind of isolated. You can kind of put a tag for your view in your hierarchy, and whatever lifecycle you need is kind of handled for you just by importing the tag. You don't really need to reach into your view from your activity or from a parent view to start meddling with things. The problem is, this is good for most cases, but what if you need like something like an expensive resource in your view, like GPS, or you're doing video playback, or something else that, as a responsible developer, you should be releasing in on-stop. Basically, anything you request in on-start, you should be releasing in on-stop. You don't get those lifecycle methods in a custom view group, so the people who are building custom views and not using fragments, they either are in the majority and they don't have a need to do that, or they're reaching into their views from from their activities somehow, and then you break that encapsulation, you break that loose coupling that you get, and you break that like component nature of what I'm getting at. Another example is like user status for a chat app. When you press home, on pause is called, and also on stop is called. But if you have a custom view that needs that data, you don't get an on stop call, so you don't know whether or not the view is currently being displayed because it's in front of the user, or you don't know if it's like in the home screen. You just know if it's attached to the activity view hierarchy, and that's kind of it. And also, there's no backstack management. One of the advantages of using fragments is that you get built-in backstack management. If you just use custom views and view groups, you kind of have to manage your own. You have to bring your own backstack. And who really wants to do that? No one really wants to implement their own backstack or whatnot. There's tons of libraries that let you do that for you, but still, that's another consideration that you have to do. But that being said, this will satisfy the vast majority of use cases, which is why like many people get away with not using fragments. But this talk is about the case, not just for the vast majority of use cases. This is meant to be like a flexible thing that you can kind of use for whatever you need. That'll scale up and down for your needs. So at this point, the Android framework team, this is before 3.0. So right now we're at this point in time, only like Android phones were out. Tablets were about to come out. The Android framework team decided they need something that has that like a little bit more generic lifecycle, that is something a little bit more powerful than on attach from window and on detach from window. And they also wanted to address the issue of responsive layouts for tablets because they were releasing this tablet platform. So they needed to introduce something like relatively quickly that'll allow you to do those things. And surprise, surprise, they bring us fragments. So what do fragments give us? They're basically like a mini activity. A bunch of developers are already familiar with the activity lifecycle. Like it's kind of like a mirroring of that. If you're familiar with the activity lifecycle, the idea was that you'd be familiar with the fragment lifecycle. But as we know, and from a certain diagram, it's not actually that similar to the activity lifecycle. But they did contain their own lifecycle methods. If you used a fragment, you can put all your lifecycle logic, all your view logic, all your logic that you would need inside of a fragment, and you wouldn't need to reach out from a higher level component into your fragment to let them know that something's happening. It would just be a self-contained, composable piece of the lifecycle that you could use. And that's really the use case for fragments. They're not really meant to be a view replacement. They're meant to be an activity lifecycle replacement. And that's why you get all these lifecycle callbacks, which a bunch of people hate. But if you need them for something like video playback or updating the status or of where the user is in the application, you need more granular life cycles, specifically when you need to release the expensive things like on start and on stop. And you also got backstack management, and everyone loves that. Everything was wrapped in a transaction, and then those transactions were kept track of. So pressing back, you can just go back a transaction, and the user was left at whatever state when they hit back. This kind of embodied the idea of a reusable UI component. It kind of handled its own backstack, had its own life cycle. It was plug and play. The idea was you could reuse them all over the place. They would be responsive. Happy days. You also get, with fragments, you also get like activity level convenience methods, because not everything you need to do, you can do from just a view or just a view component. You also need things like permissions. You might need to start an activity for a result. You might need to do something with that result. And the thing that gets the result back is the activity. And dealing with that coupling is annoying, so fragments provided a convenient helper methods for handling those results. But here are the cons. You get that really nasty life cycle. Many people probably can't tell you what each one of those things do. A bunch of those boxes are conditional and only happen in certain scenarios. A bunch of those some of that life cycle is different if you're a parent fragment or if you're a child fragment. And I think that's what really gets people, is if these fragments are meant to be composable pieces of UI, at some point you're going to want to put a fragment inside of another fragment and expect it to behave in a consistent manner. But the problem is you didn't really get that. If you had a child fragment or a fragment nested within another fragment, you would try to get it in onCreate, and you would find out that it's not instantiated yet after an orientation change. There were certain guarantees that were intuitive to expect that you would expect to be satisfied, as in, if I have a child fragment, it'll be inflated after an orientation change, that you didn't get with fragments. And they actually addressed this in last Google I/O in min SDK 24 and so the support lib. You do have certain child fragment guarantees, like after orientation change, everything's supposed to be in a consistent state, and you kind of wouldn't really have that like weird illegal state exception or weird, hey, where's my fragment? I put it in there, I rotated it, where did it go? Another really sticking point of fragments is that the transactions are asynchronous. When you commit a transaction, it's not guaranteed. You have no idea when that is actually going to be in the view state. The only way you would be able to tell is if you had the callbacks of the fragment that you just added. But what if a parent fragment needed to know about the status of a child fragment? Then you would have a hard time because you don't know when it's actually committed to the view hierarchy. But they had this method called commit pending transactions, which you would think like, hey, if I call commit and then I call commit pending transactions, I can then operate as if whatever fragment I just committed is in the view hierarchy and I can do the stuff I need to do. But the problem was commit pending transactions didn't just commit your transactions. It committed all the pending transactions for the frameworks, pending transactions for fragments, including other fragments you might have committed transaction from or fragments that were in libraries. And that just led to a bunch of inconsistent behavior and like kind of screwed with people and they didn't really understand what was going on. It was really hard to understand what exactly was happening at a given time. Asynchronous things are hard. That's why we need that talk on RxJava and handling asynchronous things. But yeah, the deal of asynchronous transactions and commit pending transactions being broken was also addressed in min SDK 24. They brought in commit now, which does what you would think it would do, which is it would commit the transactions for the given fragment you're talking about. But the problem is you can't actually modify the backstack. In the source code, the first line of commit now is just disallow backstack, whatever the method is disallow backstack something. Which means it limits the amount of like things you can do with commit now. It makes it far less useful. You still don't really have this thing that you can kind of plug and play together and kind of just build complex UIs. You kind of have to jump around, making sure you're really careful when you do things, mainly the transactions. And also, it's hard to like nest fragments, which is kind of the point of having these reusable, composable view components. So what are the alternatives today? Today, the options are like you use a view, just views with some libraries for your backstack. And there's a bunch of libraries, Scoop, Flow, Pancakes, Simple Stack. These are all real libraries, look them up. And kind of what they do is they give you simple callbacks for like on, attach, and detach. And they might also handle some backstack stuff for you. But again, they're missing these start, stop, and resume, pause callbacks, which is one of the things that fragments aim to solve. So yes, they can help you build view components, but they still don't give you that composable lifecycle thing that fragments give you. And also, what are you going to do when you need to start an activity for a result or get a permission for something? Most of these view libraries still don't give you an answer for that. And you still have to break that encapsulation, reach in from your activity and give your view something that the activity got. And you still don't have that really nice encapsulated, loosely coupled reusable view structure. So this is where Conductor comes in. Conductor is basically just a rewrite of fragments if it was supposed to be rewritten today. This is the life cycle. It's fairly simple. There's nothing conditional happening here. And it's got pretty much the same API as fragments, so you're probably already pretty familiar with it. A controller is the same concept of a fragment. It has an onCreate view. You inflate a layout. It has callbacks for the activity lifecycle. It has callbacks for its own lifecycle. It has on-detach, on-attach, on-detach, on-create view. Those are fairly simple to use on their own, pretty similar to the other libraries that there are. It's got this concept of a router, and router is like an overloaded term. On the web, it means like routing URLs, but in this context, it means like basically it's the fragment manager. If you commit a transaction to the router, it'll replace whatever view is at the top with whatever transaction you just executed. And similar to fragment transactions, there are router transactions. And the point of this is because it also has a backstack. So you still get that nice backstack that you would with fragments. But the important thing that I want to call out with Conductor over the other libraries is that you have activity level lifecycle methods like started and stopped and resumed paused, which means Conductor is at feature parity with fragments. But at this point, if it's no different, then why would you use it? But it is actually pretty different in a different slide. But you have your backstack management, you have on activity result, on permission result request in your controller or in your fragment, and the fragment analogy, it's like a controller. In your view piece, you have your activity result and on permission result. Transactions are done synchronously, which means one of the main sticking points with fragments of like inconsistent state or unpredictable state is solved because everything's done synchronously. Performance isn't really an issue because if you were using views like vanilla views, you would still have the performance hit. Like that, it's strictly as bad or better than views. But with the synchronous transactions comes simplicity. You can have guarantees that when you commit a transaction, what state your UI is in, and you can kind of like program around it without needing to worry about like, is my fragment transaction committed or whatever. You have convenient view state and instant state separation. There's a separate callback in a Conductor controller that lets you save view state that's going on versus like controller state that you want to save on a process death. And the reason why they have separate callbacks is because controllers survive orientation changes. The best way that I can explain this is imagine if you were using fragments and every fragment was on retain instance true. When you rotate the device, the instance of the controller you have is retained, and whatever you've defined in your on create view, it's called again. So if you have an alternate layout or a different resource qualifier or something going on, you can recreate your view on orientation change, but you still have all your instance stuff that you had. Like for example, a subscription or some loading state or whatever you need, you can put as instance variables on your controller, and it's all retained on orientation change. But you still get the nice process death persistence because they have callback when the controller is being destroyed due to that. And if you want to retain view state on orientation change, that's where you would use the save view state method. Like if you want to retain, the loading indicator, like restore the view state loading indicator or something like that. And all this lets you have composition by default. It's very easy to take a controller and put another controller inside of that and put another controller inside of that and say like, build up this really complex view hierarchies made up of these small, tiny Lego bricks of smaller, simpler controllers. And what that lets you do is build really complex layouts with complex life cycles and complex things that they do. But when you zoom in on in the individual atoms that you have working together, it's very simple to understand. Yeah. And here's like a simple implementation of it. It's kind of a contrived example. All it's really doing, is this a pointer? Yeah. All it's really doing is inflating a view using a layout. And this could be whatever layout you want. And it returns that layout through onCreateView. And here you call a static function to attach the router of Conductor to your activity. And what you do is you say, hey, I want you to attach this router to this container that I have. And this is just an empty frame layout. So what this router is going to do is whenever you perform a transaction on this router, it's going to put whatever controller you have in here. So whatever you've defined in onCreateView, goes into that frame layout using that router. So in this case, what we do is we check if the router already has a controller. And if it doesn't, we set the root of this controller using a transaction of this controller. You can pass stuff into this as parameters because one of the contracts of controllers is that whatever you pass into the constructor parameters, you save into a bundle immediately, and then call a different constructor so that on process restoration, you still have the stuff that you passed into here. It's similar to the reason why you can't pass stuff into the constructor of a fragment, because you need to restore the fragment on instance state. It's the same kind of concept. And also because routers and controllers have backstack management, you can override on backpress and delegate the backstack handling to the router itself. And if it doesn't have handle back, like you can describe whether or not you want your controller to handle back. If it doesn't, then just call the super. And if it does, then there's convenient router methods that you can call, which I'll go through in a little bit. So let's talk about the primitives and the APIs just really quick. I don't really want to go into the details of it because it's fairly simple and you can kind of look into it if you're interested, but just at a high level. The controller is the atom of the conductor world. It has its own lifecycle, view, and router. This is analogous to a fragment. Anytime you need to use a fragment, you can just use a controller instead. The router is what handles transactions. This is similar to a fragment manager. You can build transactions together and apply them with a router. You can also call backstack methods on your router, which I'll go into in a little bit. A router transaction has mainly three parts. A controller that you're putting into the transaction, a push change handler, and a pop change handler. And what that lets you do is you can have fancy animations when you perform a transaction. Let's say you want to fade your controller in and out, or you want to do like a flip or whatever. You could have a push change handler of a flip, and you could have a pop change handler of a flop, whatever you want. And those three things, a controller, an enter transition, and an exit transition form a router transaction. And a backstack is actually really simple to understand. It's just a list of router transactions, and that's all it is. The change handlers, as I described, they kind of do the animations of when you want to exit and enter. And when you perform backstack operations, these get applied in reverse. So this is the Conductor demo app. If you do want to try it out, I recommend you check this out. There's tons of examples, and it's really detailed. It's by the author of the library. It's really easy to understand, well-written code. And any like scenario you might want to use a controller for, it's probably here. Like for example, view pagers, nesting stuff, transitions, navigation. So here's a little bit more complicated example of a controller. This is actually from the demo app. I've converted it to Kotlin, and I've just taken a little section of it. But basically, you have a recycler view, and when like a given thing is clicked, if it's the navigation row that you see here, if it's right here, if it's that one, then you grab the router of the parent, which is kind of the recycler view. You create a new transaction. Well, rather, you're pushing a new controller to the router. You create a transaction with the new controller you need and some parameters, the pop change handler, which is fade, and the other change handler, which is also fade. And then you can tag it with a string or whatever. So you can pop two tags or whatever. Or if it's a different one, you can just perform a different router transaction. It's fairly simple to use, fairly similar to Fragment Manager. And some key router methods that are like make your life easier. You can pop your current controller, which is basically like go back. And if you have like a stack of controllers that you've formed, you can pop your current one and you can just go back. You can replace the current top controller with a given transaction. And these are just convenience methods. You can, if you have like a large stack of transactions that you formed over the course of your app, you can tag them and you can pop the whole stack back to a given tag, or you can pop all the way down to root, or you can set a new root and it'll just trash whatever backstack you have already. And then here, what's really nice about the backstack is that you have like really fine-grained control of the backstack. If you have a given controller in your backstack, you can pop just that controller and basically just like remove it from your backstack. Like for example, if you have like a login onboarding flow, Once that user is logged in, you don't want to back them into like the sign-in view, right? That doesn't make sense. They're already logged in. So you can pop just those controllers, just the sign-in controllers from the backstack. And when they back enough times, they can just go back to the home screen and they're already left in a logged in state. You can set the root of a given backstack, and that'll let you just like, it's more manipulation methods if you need it. And also you can just plain old set the backstack. And the way you do that is you just give it a list of router transactions. And as we, whoops, I think it's this one. As we see here, a transaction is like pretty easy to make. So if you have a given state that you want to recreate, creating this list of transactions is fairly trivial, and you can just set your backstack to that transaction list. So why should you use this over fragments? I've already talked about a bunch of this, but sync, async transactions are hard. Controller transactions are synchronous. It's just easier to deal with, more consistent states. And this one I didn't really think about much, but then later I noticed when you have a fragment transaction, you have to define what container your transaction is going into when you define the transaction. What that does is it takes your transactions and couples them between where your destination is and whatever thing you're trying to put in that destination. Conductor transactions, or router transactions rather, they are only the controller that you're trying to push into. That means you can create your transaction somewhere, anywhere you want, Dagger, whatever, and then you can pass it along and then have any arbitrary router execute that transaction. You have that decoupling. So if you find a good use for it, let me know. I think there's some interesting things you can do with that. They're also really lightweight. It's like they're easy to reason about. Fragments kind of have this cognitive overhead, which might be justified, might not be, but like they generally have a heavy connotation with them. But controllers are really lightweight, so you can even wrap like really small views in controllers. The surgical backstack management, which we went over some of the APIs for. It's a smaller API. There's only like 4 main classes, and the library itself is like really small. You can go through the code. It's well written, well documented. There's tests. And if it's a smaller API, simpler lifecycle, that means you can master it more quickly and you can focus on writing better features faster instead of figuring out where your fragment went. And then also because it's really simple, you get the view-like simplicity with the fragment flexibility and fewer gotchas. So obviously there are some counterpoints of why you shouldn't use Conductor, and I've tried to address 2 of them. Won't it be difficult to onboard new developers? It's like a pretty easy API, very similar to fragments. Like it's not too different. Easy code to go through. The demo app is really good. I really do recommend you check that out. There's tons of examples. And then once someone is ramped up, they're probably going to be more productive with this than they would with something that they have to constantly debug. But I haven't really proven that. That's just an extrapolation. And also not blessed by the Android framework. This is like a pretty good one. Why would you use this when the Android framework provides fragments? This is a quote from the Diane Hackborn post before last Google I/O. It says here, make it all in one activity with manual changes to its views, use fragments, a convenience framework we provide, or some other framework for split it into additional internal activities. They don't really care as long as you adhere to the activity. So there you go. Doesn't really matter if you use controllers. Fragments are a convenience, not a mandate. And also Conductor is built on views and activities. Those aren't going anywhere. And also, if you really want to know, there's a headless fragment to maintain some of the state that they have going on. And here's the Conductor library. Here's Adam Powell's talk on what the fragment. It explains really well why fragments are annoying and some of the things they did to help fix it. And also, in case you haven't read it yet, the advocating against fragments of why fragments are bad. That's what I got. Any questions? Yes. So you can kind of do it piecemeal. If you have methods in your fragment that return a view, And then if you have a method that executes things when that fragment is attached to the window, and a method that executes things when it's detached from the window, and same goes for like on start, on stop. There's direct correlations with conductor, so you just replace fragment with controller, and probably fix some of the errors that you get from that, and you're probably good to go. It's fairly easy to do it, but your mileage may vary. Anything else? Yes, this will be on the slides. The demo app is already on GitHub. I'll put my Kotlin version of the demo app on GitHub in a little bit once I'm done, and the slides will be on SlideShare or something, or at the meetup. I mean, it really depends on how you have it implemented, but because the instance of the controller is preserved, whatever you have as instance variables on your controller will be preserved. On orientation change, you will just need to figure out how to resume your view state appropriately when you come back into onAttach. Yeah. Is visible to user. Well, if you've called onAttach, then I don't know. I will get back to you. If you ask that on the meetup, I'll find an answer and get back to you. Anything else? Yeah. Your performance is probably it's probably not any worse than fragments. I don't have any metrics or empirical evidence to back that up. Anecdotally, like it's not really any visible impact. That the library itself is really small. They're not doing anything like crazy or iterating through any hot loops. I don't have any reason to believe that you'd have a noticeable performance impact. Anything else? All right. Yeah. I haven't found myself using fragments in Conductor, although because it's just a regular view, you can do that no problem. I've used Conductor with like in the same app as fragments like easily, no problem, because again, they're kind of like orthogonal. And to supplement that, I'm going to hijack there for a second. Conductor is kind of set up to be like a single activity application, like framework. But like you can just make your own activities and implement, Conductor and the activities as you like, just as you would fragments. So it's like you can pick whatever architecture you want, including MVP, MVVM, but like even whatever view architecture you want, single activity, multiple fragments, single activity, whatever, many activities, whatever. It's really flexible. Yeah. All right, I think that's it.
Thank you. I like how even on the slides where you show the method signatures, they were in Kotlin format and not Java, which seems to be important. He does a lot of Kotlin stuff. All right, anyway. Cool. So again, closing arguments. See you at our next meetup, which is at Button on June 15th. Thanks again, SeatGeek. Woo! After party is at the Swift Tiberian Lounge, which is 34 East 4th Street. I think they'll find it, but okay, across the street, and it's a half block east. And please kindly clear out. Is there a time? There we go.
Thank you for bearing with us as we renovate our lobby downstairs. I promise the way out is a lot easier than the way in. Still continue to use that elevator if you want, but we do have an option of using the stairs, which is just down a level, and we can kind of direct you down there. So yeah, got it.
Thanks. Woohoo.